This is question number 2 of the short answers, and we were really impressed with many of the answers that we saw. So here's one, for example. So first I said sketch the inverse of f of x on the same axis. So you were given this f of x is equal to ln of x. And you imagine, drawing the line y equals x, and each point gets reflected over that line. So each point on the original function gets reflected on this line. And hopefully we know that the inverse of ln of x is equal to e to the x. The second graph I asked you to do was to sketch the derivative here, meaning the derivative of the original function. So what we loved here was this person did these little pluses, which is really cool, the little and the little hairy tangent lines here. And what you can see is that, first of all, the slope is always positive, but secondly, it's really, really strongly positive for small values of x, which is indicated up here, but then it almost levels out to 0. So the function derivative looks like this, and we know that the slope, that we know that the derivative of ln of x is 1 over x. So let me just read to you what the person wrote. How do you know that the sketch of your derivative function, how do you know that it's correct? Include a description of whether the original function f is increasing or decreasing and what happens as x approaches infinity. It's all in the slope of the tangent line in f of x is equal to ln of x. And it says here as the tangent lines for ln of x are initially huge. However, they are gradually getting smaller and smaller, increasing at a decreasing rate, remaining positive. As x approaches infinity, y slowly approaches infinity. Well, actually, y is actually approaching 0. And so this is a really nice description of how we know that this 1 over x is equal to the derivative. Finally, I asked you to do a formal proof, but it was only worth 1 point. We did do this in class, and I gave you a hint: set y equal to ln of x and then raise both powers to e. So if y is equal to ln of x, then e to the y is equal to e to the ln of x. And we know that e to the ln of x is simply equal to x. So now we have this function, and we want to use implicit differentiation because y is implicitly defined in terms of x. So we have the derivative with respect to x of e to the y equal to x. Well, the derivative of e to the y is e to the y dy dx because we're going to use the chain rule there. And the derivative of x with respect to x is 1. So just using algebra here, if we divide both sides by e to the y, we get dy dx is equal to 1 over e to the y. And remember back here, we have that e to the y is equal to x. So I simply substitute that in right here, and we get the desired result, which is dy dx is equal to 1 over x.